In today's episode, we look at how electric cars are made. There's an old joke that if you're late to a party, you should arrive with a bottle of wine. And for automakers, being late to the electric vehicle market is not so funny. In fact, it could put them out of business. That's because customers are becoming more environmentally conscious and many governments have set strict goals for the auto industry. For example, by 2035, California wants zero-emission vehicles to make up half of all new car sales. Right now, most manufacturers are still working to catch up to Tesla, which has been making EVs since 2012. But soon there will be a lot more competition. Volkswagen plans to sell 1 million EVs in 2023 and Ford expects to have 600,000 EVs on the road by 2024. In the next few years, nearly every major automaker will be producing EVs. But while everyone's attention has been focused on battery technology and charging infrastructure, what we'll explore today is the nuts and bolts of manufacturing. How are these vehicles made? The first thing to know is that unlike internal combustion engine or ICE cars, which can be built on existing assembly lines, EV production requires new facilities. After all, building an EV is a very different process from building an ICE car. These vehicles don't even share many components, so automakers can't simply retool an existing line. They have to start from scratch. Take Tesla's Gigafactory in Fremont, California, for example, which produces the Model S, X, and 3. It was originally built by General Motors as a factory for the Chevrolet Vega in 1978. The plant was later used to build Toyota Corollas and then it sat empty for 5 years, until Tesla moved in. Even though the building was already massive at 5.3 million square feet, Elon Musk wanted a bigger space, so Tesla expanded the footprint to 10 million square feet. About the size of 18 American football fields. Of course, expanding a building isn't easy. Just ask anyone who's done a home renovation. So instead of building outwards, Tesla went upwards. Today, Gigafactory Fremont is 4 stories tall. And if you flew directly over it, you might mistake it for a college campus. When you think about how a car is made, you may imagine workers welding metal together, but modern vehicles are mostly put together with adhesives. This makes manufacturing faster and cheaper. Adhesives are also better for attaching to similar materials like plastics and metals, which are commonly used in EVs. Modern adhesives are also environmentally friendly. They use water-based formulas and some are even edible. Tesla uses a combination of robots and humans to attach panels and other components to the frame. While robots are accurate and consistent, they lack flexibility. So they usually perform tasks like installing the rear underbody assembly. Humans, on the other hand, are able to adapt to changes and handle unexpected situations, so they usually do tasks that require creativity and ingenuity, such as sealing the edges of windows. Another way that EV manufacturing differs from ICE vehicle manufacturing is that fewer parts need to be attached to the body. This is because the powertrain and chassis are integrated. If you've ever looked under an ICE vehicle, you'll see a bulky powertrain that hangs down from the frame. EVs don't have this. Instead, the motor, transmission, and differential are integrated into the chassis. This makes the vehicle lower and more aerodynamic, which improves efficiency. Another advantage of having an integrated powertrain is that it reduces the number of components that need to be assembled. For example, consider the rear underbody assembly, which includes the power electronics, battery pack, motor, and heat pump. This component is assembled at Gigafactory Fremont, but if it were purchased from a supplier, it would include pre-installed fasteners. This means fewer steps and less handling, which increases quality and reduces costs. Most automakers try to source parts from nearby suppliers to reduce transportation costs and improve efficiency. But batteries are one component that almost no company manufactures nearby. This is because they're heavy and shipping costs are high. So instead, automakers typically buy them from companies like Panasonic or LG Chem, which operate large-scale battery factories called gigafactories. Once the battery pack is installed, robots apply adhesive sealers to protect it from the elements. The robot arms move quickly, completing the task in just a few minutes. The next step is to install the glass roof. Robots lower the roof onto the body using suction cups, and then a sealant is applied around the edges. This helps to protect the vehicle's occupants from the weather and noise. But it also acts as an adhesive to hold the roof in place. Finally, the paint is applied to the vehicle using robots. But before that, the surface needs to be prepared. This involves several steps, including washing, drying, degreasing, and phosphating. The paint shop at Gigafactory Fremont is highly automated with robots performing most of the work. Humans monitor the robots and make sure everything is running smoothly. The paint shop is also designed to protect the environment. Overspray and other waste are captured and recycled, and the facility is constantly monitoring its emissions. After painting, the vehicles are moved to the trim and final assembly area. Here, the interior and exterior trim is added, such as the bumpers, mirrors, and door handles. This is where the vehicle goes from looking like a car to looking like a finished product. These tasks are performed by both robots and humans. Robots are used for tasks that require precision and repeatability, such as installing the front and rear fascia. Humans are responsible for tasks that require more creativity and judgment, such as installing the headliner. With robots, the trim and final assembly area is highly efficient. Workstations are set up in a way that allows workers to move from one task to another, without wasting time or effort. This helps to reduce cycle time, which is the amount of time it takes to assemble a vehicle. Before the vehicle is complete, it needs to undergo rigorous testing to ensure it meets safety and quality standards. At Gigafactory, Fremont, vehicles are tested for things like handling, braking, and crashworthiness. They're also inspected for things like paint defects and trim problems. Once a vehicle passes all the tests, it's ready for delivery. Tesla vehicles come with advanced technology that requires specialized training to service. So before a Tesla can be delivered to its new owner, it must undergo a rigorous quality control inspection. This is known as the Quality Control Drive or QC drive, and is performed by specially trained technicians. The QC drive is designed to check that all of the vehicle's systems are working properly, and that it meets Tesla's high standards for quality and performance. During the drive, technicians will test all of the vehicle's features, including the acceleration, braking, steering, and suspension. They'll also check the lights, turn signals, and other safety features. In addition to the physical inspection, the technicians will also test the vehicle's software and electronics to make sure that everything is working properly. This includes checking the infotainment system, autopilot, and other advanced features. The entire QC drive typically takes between 2 to 3 hours to complete, and is an essential part of the vehicle delivery process. Gigafactory Shanghai is Tesla's newest factory. It was completed in just 10 months, which is a record for an automotive factory. Now that it's open, Tesla plans to manufacture 150,000 vehicles per year. The factory is located near Shanghai, China's biggest city and financial center. This gives Tesla easy access to the country's growing middle class, which is a key market for EVs. Tesla has been able to move fast in China thanks to government support. The Chinese government has made it a priority to grow the EV market, so it's provided Tesla with tax breaks and other incentives. Tesla has also benefited from China's vast manufacturing capacity. The country is home to many of the world's leading auto suppliers, so Tesla has been able to source the components it needs quickly and at competitive prices. Manufacturing is only one piece of the puzzle. For EVs to succeed, we'll also need more charging stations and better batteries. We explore these topics in our videos on how batteries are made and how charging stations are made. And we have more videos about electric vehicles coming out soon, so stay tuned. As always, thanks so much for watching. I'm your host. See you next time.